you sleep during the classes, we call on you to pray. Yeah. You know, we had such a good time yesterday with the students talking about dinosaurs. Today, my wife said, "What in the world are you doing?" I said, "Well, the other day, trying to cover up my surgery, I had a dinosaur Band-Aid, and I said, I don't want to wear that to school. You know, you shouldn't be doing that when you're 80 years old. You don't wear a dinosaur. But today, I wanted that dinosaur bandage because I liked the story on the dinosaur so much from the dinosaur guy. I couldn't find I had to wear a plain one. So, yeah. Well, I know you're going to enjoy the information. Some of you may not have registered, and so there's a clipboard, and we'll allow you to sign up. We turned in our order to Chick-fil-A. I tried to up it. I can't, so we have a set number of sandwiches. If you registered, we'll have you go through the line first, get your sandwiches. Then those of you who have not registered, we're not opposed to you eating. And so the clipboard will be back at the table, and just put your name and how many people you want. My guess is that somehow we'll be able to do it because I'm going to call them again and see if maybe they can help us out with a few more. How many of you did not register that will admit it?
They won't admit.
Yeah. Okay. And if you just sign up, we'll make sure that you have Chick-fil-A sandwich. Okay.
Good. Well, good morning. We want to start the morning with prayer, and I've asked Pastor Ben Marquez to come up and give our opening prayer. So, Pastor Ben. Oh, you know, some of you know Pastor Ben. Yeah. Okay. I've been doing this 30 different times, and I've never had a round of applause for the person that gave the prayer. That's pretty cool. Okay, way to go, Wichita.
All right, brothers and sisters, let's bow our heads and pray. Father in heaven, we are grateful for the salvation that you have given to us through your Son, Jesus. And this last night, Lord, we just marvel at the creation. Your glory is on full display in all that you have created, Lord. And I just pray that today you would continue by the power of your Holy Spirit to reveal to us the marvel and the mystery of the created order. And I pray, Lord Jesus, that you would open the eyes of those perhaps who struggle in some of what we are discovering, and that you would save them and that you would sanctify them. We thank you, Lord Jesus, that your blood was shed on the behalf of all who would believe on your name, and that you would save us. And so thank you for these men, Lord, who have prepared their time and given their lives to declaring to the world your handiwork. And that handiwork, Lord, points to your eternal goodness, and ultimately it points to the redemption that is found in Jesus Christ alone. And so we're grateful for that. Lord, give us joy today. Help us to learn to fill our hearts and minds with your truth so that we might be equipped to go out into the world and to tell the nations of who you are and what is required of us. We pray all this in Jesus' mighty name. Amen.
Now I know why you got applause. Yesterday I promised you that I would explain to you briefly, because we have more important things to do, why we call this the Joshua Project when we're talking about Genesis 1 through 11, and Joshua didn't come around until a lot later. So remember this old group that got together, and that basically has evolved into what you see here today. But after we had met several additional times, after we sort of decided on this Genesis thing, I can't remember exactly, but we were in Orlando, Florida, with one of the members of the group. We're hosting us down there, our little group from Emporia. And somehow we were on some topic, Old Testament topic, and we got into Exodus and Moses. And what happened as a result of that was that we realized that that God said very directly to Moses, Moses, I'm selecting Joshua, and I want you to train him because you're not taking the people in because you got a little upset with me. And so Joshua's going to have to lead you. So you train him to take over for you. And so although all of you that are a little more experienced, you get what I mean? We're really glad that you're here. However, we spent all day yesterday with our target audience, which is guys like this and gals like that over there, right in there, and high schoolers and college students and 30-somethings, because we want to train them in Genesis 1 through 11 that they can believe their Bibles and they can carry this on, because those of us that are a little more experienced, unless Jesus comes back, which we hope, kind of looks like it's getting closer for sure, we know that, that they'll be able to take over. and continue the remnant that we have going here, that God wants to go. So that's why we call it the Joshua Project, and it may not make any sense to anybody, but we're sticking with it. That's just the way it is. So yeah. So anyway, I want you to know now that a lot of this stuff and some great teaching is on our website, thegenesisacademy.net. So the dinosaur guy that was here with the kids, his presentation is here. Dan gave a great presentation on evolution yesterday that the kids heard, the high school kids heard, and the middle school kids, or I think high school kids only maybe. But there's a lot on there, plus some great teaching like you've been listening to the last night or so. Now, moving on, today we are, well, where'd that go? I missed it. You took that off, Dan. Okay, it's okay. Last night we talked about the creation. And as somebody that watches this all the time, I felt like our guys did a great job of expressing in the 6 days of creation, not just the specifics, but they wove in very effectively, from my perspective, got across the point that there's a design to this, there's complexity to this. It's amazing. And Dave took us through the complexity of the universe, remember, with the 10 trillion galaxies and 100 billion stars in every one of those galaxies. So we're looking at a macro perspective of the complexity of God. And then we have Dan at the end with humans as an example, showing us the complexity that's in each and every cell in our bodies, depending on your size, Alex, from probably 30 trillion cells in your body, okay, to some of us that are a little larger. We may have 70 to 100 million, what did I say, 1,000? That's not right, million, a trillion cells in your body, 30 trillion. To those of us that are a little larger, maybe 70 to 100 trillion cells in our body. And how complex they are. Machines in each of those cells that can turn 100,000 RPMs a second, or a minute. I guess it was a minute. So macro, way out there, micro, and weaving in this complexity, and how can that evolve by chance? Really challenging to have that occur. So tonight, or today, we're going to move into what I call the Depression era. This is, last night was wonderful and exciting, and you came away going, wow, that was awesome. Today, unfortunately, we're going to talk about 3 judgments that have occurred in Genesis 1 through 11. The first will be Adam and Eve and their fall, and the second will be the flood, another major judgment, and then the third will be the tower judgment. But we're going to end it on a high note by talking about Jesus just a little bit. So that's where we're headed today, and we're going to start that. Now, I want you to know, for some of you haven't been in school for a while, so this is going to be some real heavy-duty science, and it's going to explain to you chapters 1 through 3 in the Bible. And Dave is going to take us through the first 2 laws of science, the basic laws of science, and he's going to use the first 3 chapters in Genesis to explain how they came about and how science actually supports the first 3 chapters, which most of natural science out there, makes fun of. So that's where we're headed, but you're going to have to put your thinking caps on this morning for a little bit. And hopefully he'll weave in a story or 2, but not 3 or 4. So here's Dave Penny, for those of you that weren't here last night.
You don't need this, Dave.
No, I don't
All
think
right,
so.
go get him.
Okay, great. We ended yesterday on the creation, and at the end, you remember on the 6th day, God said that it was not only good, it was very good with man. It was the final, we're the capstone, if you want to put it that, of the creation. And a skeptic once asked me, he says, how do you know good means perfect? And I said, well, what does it say about God? Was he good? Or was he perfect? He's perfect, but it's very perfect at the end. It's a beautiful creation. God didn't do lousy work like we do. And at the end, he produced a very beautiful creation. And we're going to see that that creation, of course, today is not what was he had built and put together for us. It's on a downhill run. But we need to understand, in the beginning, we're going to go into, there's two laws of science. I was, when I went to MIT, this fellow named, I got in there because the Sputnik was shot up in 1957, and they realized if they could, Eisenhower was president, if they could put a satellite over us, they could drop bombs on us. And everyone was building bomb shelters in their houses, in public deals. They were stocking up food and things, and you'll still see in some public buildings the radiation symbol. They had Geiger counters in case of a nuclear attack, be very imminent. And so they tested all the students in the United States, largely junior high and high school students, to see how you scored on math and science. And then they offered those that went well, and I was fortunate to be one of them, they offered you free government science and math camps in the summertime with full professors teaching. And they cranked this thing up, and I was fortunate. There was 5 of us that got into MIT that year from the state of Kansas. And I was fortunate that I cleared the boards and did well on the SAT scores, the entrance exams. And so I went there, but my education wasn't as good as those guys from those prep schools back east. I hadn't had calculus and things. And so I was struggling. That first year was pretty tough. And I got invited, however, into a fraternity there. It's very small, 35 guys, run like a monastery. I mean, it was self-imposed. We didn't have a house mother or anything, but we had quiet hours from 7 in the morning till 7 at night. Total silence. No music, no sounds, no nothing. And no dating during the week. And we had previous exams, files of them, to study for this. And your boys from down here, the Koch brothers, they'd gone through, they were ahead of me. Charlie was 7 years ahead, and then the 2 twins, Billy and Dave, had just graduated. They were still in the grad school, and they'd come over to the house. But this thing was pushy. They required that you get a tutor during this period of time. And so I chose a fellow named Chin. I didn't know, he was just a year older than I was, born in Shanghai way back, and his family had escaped the communist takeover there, here. Turns out that there's about 4 or 5 of them in this family. His uncle, through bad circumstances, was accused of being a communist by McCarthy, and he went back there and he built their rockets for Red China. It was a big mistake. Big mistake for us. He'd been a professor at Caltech and MIT. Chin, his family had stayed here. Richard, that taught me, I didn't know, he became a Rhodes Scholar. His brother became a Nobel Prize winner. That's how good they are. They're like the gods of science in China. Anyway, he tutored me, and I was struggling. I wanted to understand physics because physics is the heart of science. Biology, it's a form of chemistry. There's no nuclear changes. And chemistry is a subdivision of physics because it involves nuclear things. So if you want to understand engineering or anything else, physics is the name of the game. Anyway, I was struggling, and Chin came to me and says, Dave, I understand you're having troubles with this. I was a C+ student on that deals. And he says, let me see what you're doing. So he slapped some of these problems down. And he says, I know what your problem is. All these professors come up with new problems, but they're all built on certain laws. And these laws all come out of the first and second laws of science. And they'd been, and I'm going through those with you today. He'd never explained to me what the origin of these laws. And if you ask the scientists, what are the origins of these laws? They don't know. They said, oh, they just arose in the first nanoseconds of the universe after the Big Bang. I said, just happened. It's a stupid explanation. But I didn't know until later. I learned how to use the laws. And he took me to be an A student into physics at MIT, if you can believe that. I didn't even have to take the final exams in classical physics. And we're going to go over those laws. The irony is I think God has a jagged sense of humor, because what part of the scriptures do they laugh in the science and academia about? First 3 chapters of Genesis. No science, no history. These things are, at best, some myths that were generated. Well, what it comes out is these laws of science come out of those first 3 chapters. That's the origin. And they came from historical events in those chapters. And we'll go over this. Now, at the end of the 6th day, we have God saying it's good and very good. In the beginning, God created the heavens and the earth. We saw that. God blessed the 7th day, sanctified it, because he rested from his works, which he had created and made. Like we said, he wasn't tired at the end of the 6th day, worn out, said, I got to take a rest because I'm worn out. No, he created, as we saw yesterday, a universe with 10 to the 24th stars that we can see, of these 10 trillion galaxies. But he says the first law is the law of creation. It's an historical event. In other words, at the end of the 6th day, from that time on, there's no more matter and energy in the universe. That's all the universe is made out of. If you look around, everything's matter or energy. Those are the things. And that quantity has never changed from that day. And this is going to become the basis of the first law. If we plot this law, now this has got a pointer, doesn't it? If we plot this law, this is the time in this direction. Here we are at the present, okay? And I take this as the total energy and matter density. You can take it, if you believed, as Einstein does, that the universe is finite, you could take it as the total amount. If you take it, it's an infinite universe, you would just take that as a density, because what one part loses, the other part gains, and your average remains the same. And what this means is, if you look at it, here we are at the present time, it means yesterday and 1,000 years ago, we have the same amount we have today. And if it goes on for 1,000 or 1,000,000 years, we'll have the same amount. That quantity never changes. This is the quantity law we're going to see of matter and energy. And it's fixed to the 6th day. Universe never creates. There's no magic trick with matter and energy. There's no magicians that say they can make the rabbits come out of the hat, out of nothing. That doesn't happen. That's a trick. Since the 6th day, there's no new matter, and energy is being created or destroyed according to the first law. The natural universe, as we said, is made of just matter and energy. The 2 basic laws define the interactions of matter and energy. Every interaction is true. This is true. It's called the quantity law, like we say. The quantity is fixed. It states there's always the same quantity of matter and energy in some total before and after every interaction of matter and energy. The quantity of matter and energy in the universe is always constant. This is, out of this law, we develop about 70 to 80% of all the laws of science. They're conservation laws, just not mechanical laws, electromagnetic laws of Maxwell's. All of those things, field theories, gravitational, electromagnetic fields, wave theories, are all what we call conservation deals. They assume that no matter or energy goes to disorder. The quantity is always the same. We'll explain the difference with that in the second law. This will come afterwards. It's the implication that the matter and energy in the universe is always constant, according to the first law. Then the universe cannot create or destroy even 1 gram of matter or 1 joule of energy. So where does it all come from? This is Chesterton. He says, it's absurd for the evolutionist to complain that it's unthinkable for an admittedly invisible God to make everything out of nothing and then pretend that it's more thinkable that everything should come out nothing should turn itself into everything. In other words, they think everything just came out of nothing, even without a God or anything. And yet they reject the fact that God created it. I mean, there's something the matter. There's a disconnect there in this thinking Chesterton brings out. This is a deal from, comes from a guy that is an agnostic. He was one of the powerhouses we had in the space program, Jastrow.
During the 1920s, two of the most important discoveries in the history of science were made here at the Mount Wilson Observatory overlooking Los Angeles. For 8 years, astronomer Edwin Hubble photographed and studied the cosmos with the largest telescope in the world. In 1923, Hubble confirmed that mysterious formations called nebulae, widely believed to be enormous clouds of gas, stars, and dust within the Milky Way, were actually individual galaxies located far beyond our own. 5 years later, he verified that these galaxies were moving away from each other at fantastic speeds. Our universe, long thought to be eternal, static, and relatively small, was growing larger by the second. The implications were staggering. If the universe is continually expanding, then at some point early in its history, it must have been smaller and more compact.
If you reverse the outward motions of the galaxies and go backward in time, they come closer and closer together. And you reach a point finally where they're nearly infinite in density and temperature, and farther than that you can't go. So there is a beginning. There is a point in time from which it all started. And that's a remarkable thing because it has a very strong theological flavor to it. And that intrigued me because I am an agnostic, and if there was a beginning, a moment of creation of the universe, then there was a creator. And a creator is not compatible with agnosticism. And just as I can't believe that there was a creator, I can't believe that this all happened by chance, which implies there was a creator. So you see, I'm in a completely hopeless bind, and I've stayed there.
Robert Jastrow's uncertainty was fueled by multiple discoveries that pointed to a universe created out of nothing and governed by laws of physics and chemistry, finely calibrated to ensure complex life.
Life is so extraordinary, especially advanced life, intelligent life. Conscious beings are such an extraordinary phenomenon that, again, I just qualitatively find it difficult to believe that they happened by chance. Think of your brain, for example. It's 3 pounds of matter, contains 1,000,000 trillion synapses, as I recall, circuits opening and closing all the time. It's so much more complicated than the most advanced artificial intelligence. Again, I find it hard to believe that this is all a matter of atoms and molecules. And so I try to fit into my concept of the world the conclusion that there is a larger force of some kind, which we can call God, or you can call it whatever. But I can't accept that. I'm what's called a materialist in philosophy. But that doesn't mean I like Cadillacs and big cars. My students always used to think that. It means that I believe the world consists entirely of material substances. And when you specify those substances, the atoms and molecules, and the laws by which they interact, you've done it all. There isn't anything more to be said or inserted into your model of the universe. And that's what my science tells me, and I've been a scientist all my life, but I find it unsatisfactory. In fact, it makes me uneasy. I feel I'm missing something, but I will not find out what I'm missing within my lifetime.
Robert Jastrow died in 2008. As the founder of NASA's Goddard Space Institute and the director of the Mount Wilson Observatory, he helped to popularize astronomy throughout the world. In his best-selling book, God and the Astronomers, Jastrow described the philosophical conflict between scientific materialism and evidence for a universe that had a beginning. Far from disproving the existence of God, astronomers may be finding more circumstantial evidence that God exists, that the universe began abruptly in an act of creation. For the scientist who has lived by his faith in the power of reason, the story ends like a bad dream. He has scaled the mountains of ignorance. He is about to conquer the highest peak. And as he pulls himself over the final rock, he is greeted by a band of theologians who have been sitting there for centuries.
It's stunning, the frankness of the man. He was a great mind, but he was locked into his atheism, his agnosticism, and even though the conclusions of science are fairly clear with the creation and the fact that the universe can't create itself and it can't destroy itself, that it's very clear. And if you go back and assume that it's expanding, you go back and reverse that back in time, became closer and closer together. And we can talk about that later, what these implications are. So you have now, from Genesis 1 and 2, a beautiful creation, but it wasn't meant to be. God has bigger plans, and he has creatures out there that do not want to see him, the satanic realm. There's rebellion in it, and it comes into our line as humans. Before the fall, it says the Lord God formed man out of the dust of the ground, and he breathed into his nostrils the breath of life, and man became a living being. Then God took man and put him in the Garden of Eden to attend it and keep it. And the Lord God said, "It's not good that man should be alone. I'll make a helper comparable to him." And so he made woman. And it says, and they were both naked, the man and the woman, and they were not ashamed. In other words, like these things at the right, there was life, there was purpose, there was a unity, and there was this innocence at that point in time. After the fall, and this is in Genesis 3. I don't have time to read it, but it's the temptation that was posited by Satan. So he's obviously fallen at this point, and part of the angelic realm with him. And he comes in, and he wants to be God. We know this from Isaiah 14, Ezekiel 28, that he has this desire. And what you'll discover, as we've discovered, all of us have discovered, we've become victims of Satan's work. And all of us are sinners as a consequence of this satanic realm. And you say, well, why did God create it? We don't understand all the things, especially the origin of evil. We don't understand Satan or why he has these beings out there who are superior to us. But he comes into this garden, into this perfect world, and he's out to destroy it. And we all suffer consequences of this thing, the fall. All of us are dying. The universe is dying. The judgments were passed on it. And what you have here, it's really a tragic story. The fortunate thing is it's not the final end of the story. One's coming back. God himself is going to come back and redeem it. And there once will be in the future a world that's with us there that are redeemed because of what's Christ's work, and it'll be forever. And it'll be reestablished, and we'll be a lot better people than if we had been just Adam and Eve in the garden. God has purposes. We don't understand all those purposes. But it says, to the woman he said, I will greatly, this is God speaking, I will greatly multiply your sorrow and your conception. In pain you shall bring forth children. Your desire shall be for his husband, and he shall rule over you. This is the judgment against the woman, because Satan worked through the woman, as Paul said. She was deceived first, and then she brought her husband in. Then to Adam, these are the judgments that are passing to the man. He says, cursed is the ground for your sake. In toil you shall eat of it all the days of your life. Both thorns and thistles it shall bring forth to you, and you shall eat the herb of the field. In the sweat of your face you shall eat bread till you return to the ground, for out of it you are taken, for dust you are, and to dust you shall return. That's what we always say when we bury people. Dust to dust, ashes to ashes. It's a final thing. We return to what we were made out of originally. Also for Adam and his wife, the Lord God made tunics of skin and clothed them. This is very important because the penalty for sin is death. And God takes some of the animals, kills them, puts skin on them, and it covers. That's the word for atonement, by the way, is covering. It's not a permanent fixture for sin, but it's one that God provided, and that's why the sacrifices were so important to Israel, and why the death of Christ becomes, who is the ultimate, not just the atonement and covering. He does away. He does the total redemption. He eliminates the penalty for sin completely. But God covers them so they understand that this is the price has to be poured out of innocent blood. You say, well, why the sheep? They didn't do anything wrong. Why should they be sacrificed? Why should the animals? But the price has to be paid. So God uses innocent, not lions or tigers or those things for the redemption. It's done with a skin and a covering for them. So he drove out the man, and he placed cherubim. That's two of them. Cherub is singular and cherubim's plural. At the east of the Garden of Eden, and the flaming sword which turned every way to guard the way to the tree of life. See, the tragedy was, and they're always looking for the tree of life. You know, the Spanish conquistadors and everything were always looking for the tree of life. Do you want to have the tree of life in a state of sin? No. You don't want to live forever. None of us want to live with this sin that we can't get rid of. Even as redeemed people, we don't get rid of sin. We sin every day. And it's a disease that we acquired from Adam and Eve. It's inherent in that. Everyone inherits that nature. So this sword, by the way, I asked my uncle, he was big with Bechtel Corporation, setting up huge cities and things in Saudi Arabia. But he wasn't a believer, and even to this day, he's in his 90s. I talk to him all the time. Said, well, where'd the Saudis get all that oil? I said, are they pumping off the Garden of Eden? I said, there aren't any cherubs out there guarding it anymore. And he kind of laughed and looked at me. It's probably what they are pumping off. That's why they're so rich. The remains of the garden. And you have in this, as we say to the right there, sorrow, pain. Women all know that. Men know it. There's a curse, there's toil, there's death, and there's finally separation. It's the last time that God walked with man in unguarded things. No one's seen God's face since then, except when Christ had appeared. So we have after this is in chapter 3, we have the second law coming into effect. Before that, there's no sin, there's no decay. Everything would have lasted forever. Stars wouldn't have burned out. We wouldn't have died. Animals wouldn't have died. It would continue forever. However, with this, God somehow, and we're not sure how, in his creation maintained it in this perfect state. Because this law is a statistical law, the second law that comes in. Everything wants to statistically go to a more probable state, which is disorder. But God maintained it. And you know what? He'll do it again in eternity. There'll be a state in which the material realm will not go down. But when sin entered in, then he drew his maintenance of the universe, his personal relation to keep these things at all these high levels without anything. and he pulls back, and it starts this. Did Adam and Eve die immediately? No. But they begin this process. Everything, the stars start to burn out. They're giving off energy every day that they'll never get back. This leads us to the second law that we have. The natural realm, as we said, is all matter and energy. The two basic laws define these. The second law is called the quality law. And in every interaction, you have both the quantity law and the quality law. Both of them are in effect. And this is just called the law of increasing entropy. Entropy is just a fancy word for order, and or usefulness. And it just means that things go in every interaction. You have more disorder after the interaction than before. It's varying degrees. It doesn't go totally to total chaos. Some things do, but everything runs down. That's why you can't put gas in your car and runs forever on that tank. The energy is there. No energy is lost, but it's dissipated. And with time, and if we take this chart, this was the first law. You remember that? This is matter and energy in this direction. The first law is the total one. It's constant in every interaction. The second law is one in which it's going down. Its usefulness will approach zero. Now, we have the same quantity, but it'll be totally disordered at this point. And here we are at the present time, and we've used up so much of it. We don't know. We know this is a decay curve like that. It's called an exponential decay. We just don't know how fast it's going down. But there's an interesting point here. See that point? Do you know what that means? It's a stunning point. It means that at some point, the useful energy is equal to the total energy. You can't have more useful energy than total. You can't start with total chaos and jump up there and start down. And you can't have this in total, all perfectly ordered, and then begin this sudden decline. The universe cannot exist before that point in time. We don't know how far it is from science. From the scriptures, we'll see that we can determine what that is. This is a man that, Sanford, he's a man that I personally know. He was the father of modern, what we call genetic engineering. He developed the genes gun and all these things. He was at Stanford. He developed these, made them a fortune in this stuff, and they would transform certain things like soybeans. Before you could, soybeans would get a whiff of atrazine or another herbicide a mile away and all the leaves fall off. Well, you can go in there with his genes gun and change the deal. So now you can spray with atrazine and these things. If you do the right one, the beans, it'll kill all the weeds and the beans aren't affected. That's genetic engineering. They call it changing the, he's not creating new species or anything like that. He's just making them so that they're resistant to these types of things. And listen to what he says. This man was an agnostic to an atheist before he got in this. But his genetics leads him to these thoughts that he's going to talk about here.
The problem is so fundamental that just increasing selection pressure does not solve it. It doesn't even come close to solving it. This is the essence of aging. And so one of the things that Michael Lynch in his recent paper mentioned was he said, because of the nature of this degenerative process in our own body, there is no prospect for any type of scientific breakthrough to significantly extend our lifespan beyond what it is. That's really fundamental, and it's very personal because we are experiencing genetic entropy personally. No one can contest that. Personal genetic entropy is an uncontestable fact that no scientist on the planet can deny because it is why we die. And so what's happening is every gene in every chromosome of every cell in my body is mutating. And so that guarantees my aging and my death. But the problem is that these mutations that are accumulating in my body, some of them are transmitted to my children. And so, in fact, I take the genes, all the mutations that I inherited from my ancestors, which is tens of thousands of deleterious mutations in my body, and then I add my own contribution to that, about 100 new mutations at least, and pass it on to the next generation. So what we have here is not only this deep, kind of a personal tragedy, this is what causes us to die, but it's passed on to our children. And so it's a tragedy for all of humanity, and it keeps getting worse. It means that we are a perishing people living in a dying world. And that is so profound, and so it makes the need for salvation and a Savior so personal and so immediate, because there's no circle of life where things just keep staying the same, and it's not an upward spiral of evolution, things keep getting better and better. It is a downward spiral, exactly as described in Scripture. And so it's my research, I thought, would, I realized it had major implications for evolution, but I had I couldn't have guessed how profound the biblical implications are, how profoundly the evidence supports the biblical perspective of a dying universe and a dying world, and that we are dying because of the fall, and that our only hope is Christ.
It's a stunning deal that when you face the real science, is what we're saying, it's a stunning result. I had a privilege to speak in China to the Chinese Academy of Sciences. This is about 4 or 5 years ago. Very unusual circumstances. Normally you can't speak there. This is the highest level they got. Also spoke at Tsinghua University, which is their equivalent of MIT. And in these lectures, all the people that are participants at the academy are party members, and they're supposed to be atheists, professing atheists at this thing. So I gave this lecture, and I developed just basically what we've talked about here. And at the first, there's kind of ho-hum, what's this American saying? We know these laws and everything. He's not telling us anything new, because I was dealing in the area of cosmology. But then when I superimposed these two laws and they saw the implication of a beginning, the thing got silent. I mean, it was packed, wall to wall. People were standing up and everything, and it got real quiet. And they're listening, and you could see, and they're thinking through their minds, there must be some mistake to this. Because they explained, the interpreter, that I was trained by Chin. And I saw this Chin, 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 Chin. Then they look at me, Chin? Like, you got these things from Chin? And he hadn't drawn out the implications of the laws to me, nor the origin of the laws to these historical events of the creation and of the fall of man. And at the end, I would drive the point home. I say, now these, just like Stanford, I said, these ideas as far as the universe are very interesting and everything, but it becomes very personal, because all of us are going to die. It's going to take us down. It's going to take our society down. It's going to take our solar system down. It's going to take our universe down. Presently, the deep space is full of microwaves at 2.7 degrees above absolute zero. That's like minus 460 degrees Fahrenheit, okay? Cold. Well, that's what the radiation, they say it's the residue of the Big Bang. No, it's really what the stars have given off to this point. It just, energy goes down, 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 and gets into this big, it can't go to zero temperature, but it's at 2.7 degrees above absolute. This is the energy that's spread out through the universe. Well, I drive this home and said, but it affects each of us. And I said, with the genetics, what he's talking about, I asked Sanford, how long are we going to be here? And he says, at the present rate, there won't be any humans here because of genetic defects within 300 generations. And they can trace back, by the way, this degeneration back to one woman 300 generations ago, and to one man by the Y chromosomes to a man. They call them the mitochondrial Eve, the woman, because we all get our eggs from them, for the mother. And then the man, all men get their Y chromosomes, so they've done it all over the world, and they trace them back to two individuals about 300 generations back. And I said, well, what are you talking in terms? He says, well, if you get 20 years to a generation, you go back 6,000 years. And he says, but I said, the future. He says, they talk about genetic engineering and producing this, making us live forever. Like he explains, that's not possible. Because everyone has millions of mutations. Most of our body gets rid of most of them. But the whole human race is taking on 50 to 300 bad mutations across 7 billion people. We're on the downhill run. There's some societies where they had intermarriage. They wiped themselves out. They don't exist anymore because they accumulated too many defects. And Adam, and some people ask, well, where did Cain get his wife? Well, he could have married his sister, his mother, or anyone, because they had perfect genes. But today, you shouldn't marry within a third cousin because of this accumulation. But we're accumulating. We can see the degeneration of our genetic material in the last 100 years. It's been significant, the things we're accumulating. Well, I drove it home to them, and I said, from a scientific point of view, told them, the Chinese, we might as well go out and eat, drink, and be merry, for tomorrow we're going to die. Draw something out of the meantime, because there's not going to be anything. You're going to end up in the dust of the earth. And eventually the sun will burn up and blow up. And there won't be anything. There's no meaning to life from the scientific point of view. And I said, the only exception I know, and the only violation of this, was the resurrection of Christ from the dead. And I said, that's the only basis that we have for hope. But other than that, go out and get drunk or commit suicide or whatever you want to do to face the realities of the scientific view of the life in the universe. And so these are the things. It's a hard way of dealing with business. But this is the realities that we all face, not just the unbelievers. The unbelievers, they don't have any hope. They're on a ship that's sinking, and there's no way you can plug the holes in the bottom. The universe is going down. And eventually, when all the stars are burned out, all the galaxies are dead, this energy that they have is spread out through the universe. It'll rise up to about 4 degrees, this microwave. Nothing's lost. It's all there. Let me give you an example of the difference between the two laws. I don't know what it is about boys, but if they see a perfectly calm pond out there, they have this impulse to pick up a rock and throw it out into there and disturb the lake, okay? I don't know what it is, every time. And what they do is, but that rock, right before it hits the water, it has energy. If you could convert that to electrical energy, batteries and things, it'd run little cars for a long time, that energy. But it hits the water, sends out waves, goes to the bottom, pretty soon it's calm again. Well, from the first law, where'd your energy go? The molecules in the lake are vibrating a little. The lake's a little bit warmer than it was before the rock hit it. But then eventually, it'll give its energy off to the atmosphere, and that'll give it into space, and it goes into this big ocean of microwaves out there. But if it wasn't true, the second law wasn't true, if only the first law was true, that lake, it could gather up, the molecules in the lake come together, and they pick up that rock off the bottom, the waves come together, and they throw the rock back at the kid. The first law wouldn't be violated. But the second law says, no, you can't do that. You have to distinguish between the two laws. Both of them are true, but one of them sets the pace and balances the books, but the other one says, no, you can't. There's certain things you can't do. You can't go from disorder to order. Let's look at and this is another thing that I did in some other presentations. What are the implications of these two laws as far as origins? And we saw some of them graphically. You have two choices with the first law. Either all the matter and energy is there, it's been always been there, forever. It's eternal. Or it was created supernaturally by an external agent to bring it into being. The Big Bang won't do it. I don't have time to go into that. The Big Bang is not even a serious hypothesis, if you want to put it that way. It violates every law of science we have. Conservation of momentum. You have an explosion and every amount going in each direction. Well, universe is lumpy. There's no place you can stand and have an equal amount going out. Also in an explosion, you never get rotary motion. And everything in the universe has to be in rotary motion or the big bodies will suck up the small ones. You take our galaxy, for instance, in conservation of angular momentum, you bring it back to the original body. It's spinning at the maybe a Google times the speed of light, 10 to the 100th. And it can't spin faster than the speed of light. Where did it get its angular momentum? Gravity won't do it. Gravity acts from center of mass to center of mass. You don't get rotary motion. And yet you have to have it or the big bodies will suck up the small ones. It gets even more serious. You look at, say we've put up, 10,000 satellites. They either go down or they go out. To find the balance where you get the gravitational pull balanced by the centripetal, or centrifugal, some people will say, acceleration, you got to balance that exactly, or it'll go down or go out. And that's to get a stable orbit. That's only a two-body system, the satellite and the Earth. We cannot mathematically even do anything for a five-body system to get stable orbits. We can do the mathematics, and yet we live in a solar system of 100 bodies, 9 planets and 90 moons. But to put them into perfect orbits, that they're stable, that's just one satellite. That's one star's solar system. We're just in our galaxy, 200 billion. And a lot of them have solar systems, planets around them. And you say, how does this happen? And you see galaxies that are basically in stable rotations with 100 billion stars. How can you do that? This was the thing that my roommate at MIT, he's became the master of the space program. He did the equations for going around the moon in the Apollo project and everything. He does the one for the interplanetary stuff to make sure they get there. If you want to end up with this 600 feet of the target on the moon or on Mars, he was the guy that could do those calculations for them. And he did the stuff, the probes going way out, because they used a slingshot method. You come in, you don't have enough power to shoot all the way out to Pluto, so you shoot out, and this thing's moving. You're going to hit a target 100 million miles away, and you come in right behind it, you see, within a 2 to 5 mile range, and the gravity of that planet will sling it on out. And they just slung them out. They hit 6 of them. You talk about mathematical geniuses. And they slung them all out beyond Pluto. The Voyager and the, what was the other one? Pioneers did those. Those are genius guys. But like he said, this led to my best friend at MIT becoming a believer. He says, this thing is just impossible. I said, don't you talk about these at high levels? He says, no, it's the wrong model. Everyone laughs. It's just not possible.
What was your friend's name?
Bob O'Donnell. They keep him secret for the most part because he did some stuff that they tried to, during the Cold War, tried to kidnap his boss. And so there's certain people in this country that have protected us. And because they don't do just this. The Cold War, the space race was a part of the Cold War in the end. The technologies that were developed were to protect us from bombs and things, all that type of stuff. And these guys were weird deals. But these laws, you've got two choices. Either the matter and the energy is eternal, or it was supernaturally created. You don't have any other choices, logically. The second law, however, eliminates the first possibility, because it says there's a point in time at which all of it was useful in one particle or something. Since the universe is not eternal, but rather began a finite time ago and is now dying irreversibly, incapable of giving itself naturally giving itself order. So we are left with only one viable conclusion. The universe was supernaturally created and ordered by an external agent a finite time ago. This is a scientific conclusion. I mean, it's you put it together. That's why the Chinese were, there's got to be some deal, because you can't be an atheist in this situation. There's some more implications. The second law that requires an external agent supernaturally to create the universe out of nothing also supernaturally gave the universe its order because of the second law. Something had to give it this order. For instance, to give you an example, well, I'll talk about that. Additionally, he must have these characteristics. This is all science. This isn't philosophy, this isn't religion, this isn't anything except hardcore science. It had to have more energy than the universe to give the universe its order. That's not to create it, but just to give it. For instance, to create a star, you've got to go back to its beginning point. You have to be able to collect all the energy it'll ever give off to go back to its beginning point. And that requires more energy than that star will ever give off in its lifetime. And if you do that for one star, you got to do it for all of it. So you have more energy than the whole universe just to give it order, not to bring it into being, just to give it order. Secondly, it has to be immaterial. And the reason you say that, we know how big the universe is. We can see out with these Hubble and then this Jack Webb. We can see a long ways out there. And if there was an explosion, this thing, or say you're limited to the speed of light. You start on this side of the universe, putting stars and galaxies together, and by the time you get here, those are dead. Do you see what I mean? And no matter can travel faster than the speed of light. So you can't get out there. Everything's dying. But we know from explosions, novas they call them, in our own galaxy, the Milky Way, they're in every direction. So they came into being at the same time. Okay? Now we see about that's happened every day or two. Every year or two we see what they call a supernova. And they're outside of our galaxy. We don't know if it's a whole galaxy blowing up or a big star in a galaxy, tremendous explosions. And these are taking place in every direction too. So you know that this thing came into being and they're dying at the same rate from every part. So whoever put them together had to be able to access them almost instantaneously. So it can't be made out of matter. And some will say, well, it happened at the Big Bang. The Big Bang when it was all together. Well, the temperatures of the energy that would be there are so hot that matter can't exist. So in any case, this agent is not made out of matter. It's immaterial, either having to travel faster than the speed of light or to work in conditions that are hotter than any matter can exist. That's this one. Anything that's built, the agent that built it has to be more complex than the thing that's built, like a watch. I know there's a watchmaker or watch factory out there that's more complex than the watch. Everything that's built has to be more ordered, like you. You can only be built as well as your DNA. If you lose parts of the DNA, you're defective. And they can't take monkey DNA and make a human out of it. It doesn't have enough information. Anything that's built, I don't care if it's a machine. I see a Caterpillar tractor, I know there's a factory someplace that built that thing. And it was more complex than that tractor. Everything that's built has to be more complex. So this universe that we're looking at, the agent had to be more complex than the most complex part of the system. Well, that's humans. Unless you believe in aliens, I don't believe in aliens. Then they have to be more complex than those. So this agent is not just some force. It's got intelligence, it's got emotion, it's got will. It's more complex than we are. So you've got three characteristics. More energy than the whole universe, not made out of matter, and is more complex than man. Now, one guy said, well, it's time to use the G word, isn't it? And that's true. There's only one agent that we know that is that way. that's a supernatural agent that has attributes of God that fulfill those requirements, those scientific requirements. What we have, and we'll go on to this later, is that science will drive you to not only a creationism, we don't know the time frame from it, we do from the scriptures, it leads you to a very defined characteristics of who God is. And it's like in Romans 1 says, they are without excuse because even the invisible things of God, namely his divine power and deity, are clearly seen in what? They're invisible, but they're clearly seen in what? The things that are made. So they're without excuse. So when I look around, and we used to take our kids, it was interesting, we point out different things and say, we point to a car and it says, who built that? Oh, men did. Then we point to a tree. Who built that? Is there a tree factory around here we can build those? And everything. I said, and you got to be careful with your eyes and your hands because we don't have eye factories that can fabricate eyes. Or we don't have ears or anything else. So be careful with your eyes and your body and everything that you don't lose parts of it. Because there's not a factory we can go and take them. I have a family, half my family are medical people, and some of them are unbelievers. And say, well, I say, when are you going to quit practicing medicine and really do medicine? And one of them said, oh, we got a real problem. We're trying to work on something we didn't build. And I said, that's right. And so they're trying to repair something that they didn't build. And the human body, as we're finding out, is so complex that I don't think they'll ever figure out how to build one from scratch. You can build things genetically by artificial insemination, things like that, but you don't start from scratch. And you can't design it. We can't even figure out how it runs, most of it. And we can't even fabricate a blade of grass. We're living in something, we can't create any of this room, any of this world we live in, either the non-living part or the living part. There's not a factory that can produce any living system from scratch. No place. And how can you be, like it says, Romans 1, you got to be willfully blind to say that you don't understand the divine power in God, his characteristics. Because every one of us, I like this with machines, I can tell from a machine, this ability I have, I can draw a profile of the guy that built it. They leave their mark in everything. An artist, she leaves them in, or a man, in the way they build them. Paint, or the music they make, Bach. Beautiful stuff. Or the machines that I've seen. People left them. I had a guy that was majored in commercial art, had a degree in that, but he's welding up stuff for me. He not only made this stuff functional, it was fancy. It had little characteristics, not only his signature welded into it, his initials, but he built the thing in a way that was not only functional, it was pleasant to look at. It wasn't a beast of a thing, because these cutter heads and everything we're building are beasts. They tear up everything in front of them. And yet it looked good, but it would still tear up this stuff. And you look at a clock. I like to take these old vintage clocks and reactivate them. And these things are masterpieces of just all those parts moving, and how you can just adjust them a little bit and they run faster or slower, or whether they have pendulums or wind up deals. It took a lot of centuries to get the refinement that they can get one of those mechanical clocks to work. Well, yeah, questions?
Hypersonic travel.
Yes, sir.
What does the future hold on that?
I think that it's not necessary. They're using it for rockets and things like that. Makes it dangerous that they can get things coming in fast at us. say from Russia or China. For transporting people, though, the Concorde was a supersonic deal. You're talking about hypersonic, which is even higher. It's terribly inefficient. You're fighting a lot of drag, and you're creating there's a tremendous waste of energy in the process. They're very inefficient. And so you say, is it necessary to cut the time to go to Europe from, say, from New York to Paris from 6 hours, 7 hours down to 3 hours like the Concorde did? They never made any money on any of their flights. But to go hypersonic and get there within 45 minutes, I don't think that it's worth it. That's my personal deal. It's all a question of energy, efficiency. Now, what these are built, they're built on the concept of what we call ramjets, where that you actually get the thing up to a certain speed so it crams the air in there. You don't need compressors on the front end. And you're kicking stuff out, but you're burning a lot of fuel. You got a lot of drag. On the X-15, for instance, those were reaching speeds of about 4,500 miles an hour, and they'd shoot them up their rocket plane. They'd shoot them up, and there's not much drag up there, but then they come down, and it was so hot, the energy loss, it'd glow. The whole surface would glow. Guy looking out of there could see everything glowing in front of him. And he has to come in at about 300 miles an hour, and they didn't have wheels on the back. Came into a skid and just the wheels on the front, and they'd come down hard. In fact, they've been them. There are only 3 of them, actually, I think, ever made. And there's only 2 of them in existence, I think. And one of them's over there in Columbus, I think, at the museum over there. And I've actually been up to touch them. They're made out of steel. It's just a high-speed thing. But you can do it, but the question is, what do you achieve by it? And for transporting people. For transporting bombs, I can understand it. But it's not something that you would do for transportation. It's too energy inefficient. Yes?
What's a good way to, the evolutionists that talk about these stars being millions of light years away and how that proves millions of years, what would be the best way to counteract that, or how would be the best way to explain that?
Okay, I don't have a, yeah, the question is how do you explain with the vast dimensions of the universe that it takes light to travel so long that it shows that it would be millions of years old, and how do you answer that question? The trick is that the speed of light is not a constant, as Einstein said. And this was developed 40 years before him by Maxwell. And I don't have a chart, but it says basically c squared, the speed of light squared, is equal to 1 divided by the strength of the electromagnetic field that the light's traveling through. For instance, that's the denominator in diamonds. The electromagnetic fields are very strong, so the speed of light goes down. It's 1/2 of what it is in the air. Now, the question is where do those electromagnetic fields come from in space? Because we have light coming from distant galaxies, okay? Well, your electromagnetic fields, they thought there was ethers out there. There was matter, some mysterious matter that gave space these electromagnetic properties. That's not true. What it does, everything that we have, all this matter we have is made out of subatomic electric charges, electrons and protons, whose fields go out into infinity. Very strong fields, but they disappear very quickly with distance. So as you get away from celestial systems, which have a lot of these charges, their fields become very weak in distant space, interstellar space, intergalactic space. Those will approach, the denominator approaches 0. What will happen to the speed of light? Approaches infinity. So in deep space, in intergalactic space, your speed of light's very fast. If Einstein's speed was true, the nearest star, Adam and Eve wouldn't have been seen for 4 years. But in reality, they saw all of them in a matter of days. And they would say, like the North Star, Polaris, is 70 light years. That means the light coming from it is 70 years old. When in reality, it's probably only a matter of hours old. Because if you're around a celestial system, the speed of light will be slow, but as you get into deep space, it'll pick up and it'll book a long time. Then it comes to another celestial system, it'll slow down again. And so what you have is the light from very distant galaxies is probably only a matter of, the most distant we see is only a matter of years old, because it's coming through space. And also, it will lose some energy in that entropy. So what do you get? A red shift. So instead of saying these things are moving away at the most distant, they're actually stationary, and the light is weakened so that it becomes redshifted. You get the Doppler effect that they say, well, this shows that they're accelerating away, and they're not.
There's a young man that had a question in here, I think.
Yeah, go ahead.
Take care of these young people first.
Okay.
What do you think about electron drives, and do you think they'll ever be able to be used for anything?
Yeah, it's a question of electromagnetic drives. Will they be used? You remember that Red October, that submarine? That was built on the drives. It's where you could accelerate water by using electromagnetic fields and the charges in atoms in the water and things. I'll tell you, the problem is that there's an equal amount of positive and negative charges in all matter. So you don't have any net charge to work with. And so putting a field on it, it's not going to have much of an effect. You know, you have to induce into it some charge into the water and then use that to accelerate it out like a submarine. They'll never use it for air, I don't think, but it'll be for water. They might be able to use that, but it's very inefficient. A lot of fields won't move much water.
The lady back here.
Yeah, yes.
Can you explain the flaws with carbon dating?
Okay.
Briefly.
Okay, briefly. That's due to radioactive decay. What it is that radiation comes in the upper atmosphere, hits nitrogen-14, turns it into carbon-14. It's brought down to the surface of the Earth and as CO2. And so it's about, of the CO2 in the atmosphere, let me tell you how thin. CO2 in the atmosphere is only 1/25th of 1%. Okay? It's almost non-existent. We got 20 times more argon in our atmosphere than CO2. Okay? So if you take that 1/25th% and you got 1 part per trillion of carbon-14 CO2, you're making a very small amount, and the half-life of it is like 5,700 years, 5,170 years. So every 5,700 years, you lose half of it. Well, what's interesting about it is that after about 15 half-lives, about 100,000 years, there won't be any. It doesn't exist anymore after. And yet everything that has carbon in them, including diamonds, which are supposed to be 1 billion to 3 billion years old, have carbon-14 in them. And if you date them, they come out to about 50,000 years. But the problem is there were some tests done back, this is 1966 or so, a group out of Berkeley. This is when I was after I was a student. They measured trees. Bristlecone pines lived to be, 3,000 years. They did rings and carbon dated them. Well, they're pretty accurate back to the time of Christ, and then error began to set in. The way you have a constant amount is the amount coming down from the upper atmosphere to here. The amount decaying off here is equal to the amount coming down. That's where you have homeostasis. Well, they checked that, and it's pretty accurate, the rings to carbon dating, back to the time of Christ. But by the year 1500 BC, you got 100% error. And the question is, was the atmosphere messed up? Probably so, maybe a flood or something. So when they use carbon-14, it can only be used, we have other systems, uranium to lead or rubidium, strontium, argon, potassium argon, argon to argon. But use two different methods on things and they never come out the same. They're not even in the ballpark together of any sample I've ever seen. But carbon-14 is nice because it's a short term, but everything that has carbon in it has carbon-14. And none of it should, if it's less than more than 100,000 years, even theoretically. It can't. And that's if the atmosphere is the same as today, but it wasn't. So this is, I don't have time to go into it, but this is, when you look under, what I say is when you look under the covers, you realize things aren't what they're telling you is. You know, it's bad science.
Question in the back.
Yeah, go ahead.
I heard that another problem with carbon-14 dating is that when something's exposed to water, that it leaches it off faster, and so if anything were exposed to water, then it would introduce more air. Is that correct?
I don't know. Their assumption is that there's no contamination, there's no loss. And that's just not possible with any sample. So it could be water, it could be anything else that does it. But diamonds, we do know that they date. It's the hardest material, natural material that exists. There's no penetration where carbon-14 got into it, you know. So and it dates at 50,000, 60,000 years old. Well, all of them date about that. Everything in carbon-14 dates about like that. There's a few that are shorter than that, but they have some real problems with this contamination and decontamination, you know, of loss of stuff. There's
One more question, Lisa, and then we're gonna go to break about 5 or 10 minutes early. Okay? Okay, Dave, one more question?
Well, that guy there had one. I'll take two of them here.
Okay.
Go ahead.
Well, I'll defer to her.
Okay, go ahead.
What's your perspective or thoughts about the COVID shot?
That's very political.
Dave, here's a hot potato.
I'm not against vaccines, but I'm against this one. They're messing up with the immune system, and we're very strong alternatives. Hydroxychloroquine, ivermectin. You take that with a Z-Pack to prevent it. I never took a shot, and a number of people I did.